Lesson 4, determining number of triangles. So the ambiguous case is when you have a triangle and based on what information you're given is not enough to know if you're going to have one triangle or two triangles. So there's only three options. You can have one triangle, two triangles, or no triangles. It doesn't make a triangle. And the ambiguous case happens when there's two possible triangles. One with an acute angle and one with an obtuse angle. So the circumstance that happens is when you know side, side, and angle. So you can know this side, and this angle. You can know this side, and this angle. You can know this side, and this angle. This side, and this angle. This side, and this angle, or this side, and this angle. Notice that there's no angle in between the sides, because if that was the case, it would be the cosine law. So these are the options where there could possibly be an ambiguous case. So if you have a triangle, and you are given this angle, and you're given this side, we'll call it A, so the side opposite it, and another side, we'll call it B. When you are testing to see if you have the ambiguous case, there's a few things you can look at. The first thing to check is if A is greater than B. So if you find that the side across from your angle is bigger than the other side you've been given, you will have one triangle. And that's all you have to do. If you find that A is less than B, there's going to be three different options. And the way that you test that is you're going to find the height of the triangle. So if you imagine that this is your triangle, you're given A, this is the angle, and you're given B, you're going to find the imaginary height that would make this angle a right triangle. So to find that, you're going to take the sine of your angle is equal to H over B, the side you've been given. So really what you'll type in is B sine theta is equal to H. When you type that in, if you find that A is equal to H, so this number right here is equal to the H that you find, you have a right triangle. There's one triangle possible. If you find that A is less than H, that means that in this triangle it doesn't even make it far enough to make an actual triangle. So you'll have zero triangles. If you find that A is greater than H, what that means is the triangle could either go this way or it could go this way. So there's two possible triangles. So first you have to test if A is greater than or less than B. Then you have to test which version of H you need. So for our first example, notice that our angle is the same and the side that's not opposite our angle is the same. So we're going to first use that to calculate H. So if you imagine this triangle, we have 30 here. This is our A or our H, and this side is our B. So we're 12. So the sine of 30 is equal to H over 12. 12 sine 30 is equal to H, and you should get 6 is our height. So we're going to compare everything to 6. So for A, we know that our A is 4, our B is 12, and our H is 6. We know that A is less than H. We also know that A is less than B. So because A is less than B, there's three different options. So now we're going to do A is less than H. And because 4 is less than 6, There's no triangles. So if you were to sketch that triangle, it would look like this. It wouldn't actually fit. For part B, we know that our A is 6, our B is 12, and our H is 6. So A is less than B. This side is less than this side. So we have to go on to H. And we know that A is equal to H. 6 is equal to 6. So there's one possible triangle, and the triangle that we would have is a perfect right triangle. C, we have our A is equal to 8, B is equal to 12, H is equal to 6. We know that our A is less than B, so we have to go on to our H's. We know that our A is greater than B because 8 is greater than 6. So there's two possible triangles. And for D, we have our A is equal to 15, B is equal to 12, H is equal to 6. A is bigger than B because 15 is bigger than 12. So we already know there's just one triangle. So that is how you determine the number of triangles.